Alright, so I'm going to go ahead and get started with this one. It wants me to solve the following quadratic-like equation. So with these, anytime that this power is twice this power and has no x at the very end, we're going to attempt to factor it like we normally would. The only difference we're going to have is instead of the x and x that we're used to putting here, we're going to use this middle term, x to the 1/4 in this case. The rest of it's going to be like normal factoring. What multiplies to get 6 but adds to -5? We're going to need two negatives to pull that off, and the numbers that do the job are 2 and 3. That means that we have x to the 1/4 minus 2 equals 0, or x to the 1/4 minus 3 equals 0. Or in other words, x to the 1/4 equals 2, or x to the 1/4 power equals 3. Now to take care of the 1/4 powers, I'm going to raise everything to the 4th. That'll eliminate the fraction exponent. So we have x equals 2 to the 4th, which is equal to 16, or x equals 3 to the 4th, which is equal to 81. So that means our answers for this problem are x equals 16, x equals 81. Now for this one, it wants us to solve the following equation by factoring. And since all of these powers here are all over 5, I'm going to take this smallest one here and factor it out. That'll give us y to the 6/5. The 5 won't change, but for the y's, I'm taking 6/5 away from 16/5. That'll leave us with 10/5, or just 2. The 28 won't change, but the y's will. 11/5 take away 6/5 is going to give us 5/5, or just 1. And we're taking the entire y to the 6/5 out of this last term, so we're just going to get plus 32. So that'll kind of give us one of the answers pretty much straight away, because we'll have y to the 6/5 could be 0. And the only number that we can raise to any power and get 0 is 0. So that's a gimme. Y equals 0. The other option is that 5y squared minus 28y plus 32 could be 0. And in order to find out what y's work for this, I'm going to use the quadratic formula. So y in this case is equal to negative b, or just 28, plus or minus the square root of b squared, so negative 28 squared, minus 4 times a, which is 5, times c, which is 32. And all this is going to be over 2a, which is 5 in this case. When you take negative 28 squared and subtract what you get when you get 4 times 5 times 32, that's going to give us 144. So y is equal to 28 plus or minus the square root of 144 all over 10. Now the square root of 144 is 12, so that'll give us 28 plus or minus 12 all over 10. So if we look at the addition first, 28 plus 12 is going to give us 40. So 40 over 10 is one possible answer, which is the same thing as 4. The other would be the subtraction, 28 minus 12, which will give us 16. And that over 10 simplifies down to 8 over 5. So our answers for this problem are y equals 0, y equals 4, and y equals 8/5. For this one, we need to add or subtract the rational expression. In order to do that, we're going to need a common denominator. The easiest one to use is just to multiply the two things on the bottom. So my common denominator, I'm going to use x plus 5 and times that by x minus 2. This will be my common denominator. So if I start by looking at the x squared plus 2 over x plus 5, in order to get to the common denominator, I'm going to have to multiply this by x minus 2 over x minus 2. When I multiply this out, the bottom will be my common denominator that I want. And the top, when we multiply it together, we'll get x to the third plus 2x minus 2x squared, and then minus 4. When we look at the right side, x minus 6 over x minus 2, I need to multiply that by x plus 5 over x plus 5. Again, on the bottom, I'm going to get my common denominator because I'm planning on doing this. And on the top, when I multiply these together, I'm going to get x squared plus 5x minus 6x, which is minus x, and then negative 6 times 5, which is negative 30. The sign in the middle will stay the same. We're still subtracting these. Now when we combine the overall answer, the denominator on the bottom here is still going to be the same thing. Our common denominator that we defined from the get-go. Now when we actually do our subtraction, I'm going to start with the highest powers and work my way down. I'll have x to the third, because there is no more x to the thirds besides the 1. Negative 2x squared minus x squared is minus 3x squared. 2x minus negative x, which is the same as adding x, will give me plus 3x. And then negative 4 minus negative 30, which would be the same as adding 30, will give me plus 26. And since nothing here is going to cancel out, this is going to be our final answer. Here it's just asking us to solve the equation. So since both sides, the left and the right, are to a fractional power that has 5 as a denominator, I'm going to just instantly raise both sides to the 5th power. What that'll give me is I'll have the x minus 5, but instead I'll just have squared, and I'll still have the 7x minus 45, but it's going to cancel the 5 on the bottom and it'll just be 1. The left side I'm going to have to actually multiply out. That'll give me x squared minus 10x plus 25. And on this side, nothing changes. Now, since it's a quadratic, I want everything equal to 0. So that'll give me x squared minus 17x and then plus 70 is going to be equal to 0. I'm going to go ahead and attempt to factor this. At this point, you could use the quadratic formula or any other method you would like to use, that's fine. I would prefer factoring. So that'll be an x and an x. Since it's plus, and we're going to add to a minus, we're going to have two minuses. And the factors will be 10 and 7. So that'll make x equal 10, x equals 7 as our possibilities for answers. Now we have to check these and make sure that they work. I've already pre-checked these. Both of these answers do work. During the test, all you'd have to do is take 10 minus 5 and raise it to the 2/5 power. Take 7x or in this case 70 minus 45, raise it to the 1/5 power, and verify that it works. For this problem, we need to solve the rational equation. The first thing you want to do is factor anything that can factor. Here on this bottom right here, I'm going to change that because it does indeed factor down into 2y plus 1 and y minus 2. Anytime we have a rational equation, we can eliminate the rational part of it. I'm going to multiply the entire equation by everything that shows up on the bottom. So 2y plus 1 and y minus 2. When I multiply this to the first term, it's going to cancel out the 2y plus 1. It'll leave the 3, but it'll only be multiplied by y minus 2. When I multiply this to the second term, I'm still going to have this minus here, and it's going to be y, but the y minus 2 will cancel and leave 2y plus 1. On the other side of the equal sign, when I multiply it there, it's going to cancel the entire bottom. And it's just going to leave what's there on top, negative 3y squared plus 2y plus 43. Now to clean the left side up a little bit, when I distribute this, I'll get 3y minus 6. We have to make sure on this one we take the negative y to both things. So we'll have negative 2y squared and minus y. And that'll be equal to the negative 3y squared plus 2y plus 43. So now, since we have a quadratic, I want, both sides Since we have a quadratic, I want it to be equal to 0. So I'm going to start moving everything on this side over to the other side. Now what that's going to do is that's going to effectively eliminate the right side. So what will be left is 0. And on this side, the 3y right here is unaffected. Minus 6 minus 43 will give us a minus 49. When we have negative 2y squared and add 3y squared, we just get plus 1y squared. And then negative y minus 2y is minus 3y. So now when we look at this, we have a 3y right here minus 3y. These are going to cancel. This will leave us with y squared minus 49 equals 0. Which then gives us y squared equals 49. And when we take the square root of both sides, that'll give us y equals plus or minus square root of 49. Or in other words, y equals plus or minus 7. Those are going to be our answers for this problem. This next problem says, including tax, Roberto pays $6,349.40 for a sound system. The price before tax was $5,990. What was the tax rate where Roberto lives? So we know that normally, if we know the price of something, in order to see the tax rate, we have the price plus the tax is equal to our sale price. So we know what the price before tax was. It was $5,990. We're going to add the tax, which is a percentage of that price. So it's going to be the rate times 5,990. And that's going to equal our sale price. 6,349.40. Now on this side over here, I can factor out 5,990. And what I'll get is 1 plus r, which is still going to equal the same thing on this side, since nothing on this side has changed. We're going to get 1 plus r then is equal to what we get when we take 6,349.40 and divide that by 5,990. Now what I'm going to get is I'm going to get 1 plus r equals 1.06. To find the rate, I just need to subtract that 1 from both sides. And I'll get r is equal to 0.06. Now 0.06 is not what it wants, that's the decimal form. It wants to know the tax rate. So the rate itself is going to be whatever that is times 100, which is going to be equal to 6%. Two trucks leave a warehouse at the same time. One travels due south at the average speed of 63 miles per hour, and the other travels due north at an average speed of 61 miles per hour. So this problem wants to know how many hours it will take for the two trucks to be 496 miles apart. So if we can get an idea of kind of what the situation is, let's say here's where their starting point. One's traveling due south at an average speed of 63 miles per hour. The other is going due north at a speed of 61 miles per hour. So if you look at this, we can see that after 1 hour, they're going to be 124 miles apart. If one goes 61 miles per hour for an hour, he went 61 miles. Same with 63. So since they're going directly apart in opposite directions, how far apart they are after 1 hour will just be their rates of speed added up. So we want to know how many hours it's going to take until the two trucks will be 496 miles apart. So they're going to go 124 miles apart times the number of hours that they travel, and we want that to be 496. From here, to find the hours, we just have to divide by 124, which on this side will give us h, and on this side it's going to give us 4. So the answer that Hawks is going to want is 4 hours, is the amount of time it takes for them to be 496 miles apart. Now we need to solve the following absolute value equation. So here we have an absolute value is equal to an absolute value. The only way for two things to have the same absolute value is if they're the same thing, like the absolute value of 3 is equal to the absolute value of 3, of course. However, the other way for two absolute values to be equal is if this absolute value, or the number that's inside, are the exact opposite. Absolute value of 3 is equal to the absolute value of negative 3, for example. So I'm going to use these two instances to solve this problem. So one option is the two things that are in the absolute value could be identical. So we just set the two things equal. That's one option. The other option is, what if the things that are on the inside of the absolute value are exactly the opposite? So I'm going to keep one the same and make the other completely opposite. Now I'm going to solve these two separately to find my two answers. So over here I'm going to subtract 3x from both sides. That'll give me x on this side. X minus 8 equals 5. And then I'm going to add 8 over here. So x equals 13 is one option. Over here, I'm going to add the 3x to get 7x minus 8 equals negative 5. And then by adding the 8 this time, I'm going to get 7x is equal to 3. So x equals 3 over 7 is my other option. So x equals 13, x equals 3 over 7 are my two answers that will give me the same absolute value in both of these equations. Now for this one, we're asked to solve the quadratic-like equation. For problems like these, we want to notice that this thing is identical in both places. So we basically have one thing being squared plus 7 times that thing minus 30. Whenever we have this, we're going to say, okay, I'm going to call A this repeated thing. In this case, y squared minus 6. Now, if we put A instead of that into the equation, that'll change it to A squared plus 7A minus 30 equals 0. Which is nice for us because now we can factor this where we couldn't before. Instead, I'm going to use A and A. Since we want to multiply to negative 30, we're going to want a minus and a plus. And I'm going to use plus 10 and minus 3 to factor this. So our options are A plus 10 could be 0, or A minus 3 could be 0, which would mean A equals negative 10, or A equals 3. But A is not what the question asked for. This problem wants to know y. So I'm going to put what we substituted back in. So I have y squared minus 6 equals negative 10. Or y squared minus 6 equals 3. Which will give me y squared equals negative 4. Or y squared equals 9. When we take the square root of both sides, we'll get y equals plus or minus the square root of negative 4, or y is equal to plus or minus the square root of 9. So that'll mean y is equal to plus or minus 2i, or y is equal to plus or minus 3. And that'll give us our 4 answers that are needed for this question. This next problem wants us to simplify the following square root expression. Right off the bat, anytime we see the square root of a negative, we instantly want to change that to instead be an I. So I went ahead and did that there. So instead we have 8 plus I square root of 6. Now when we square something, we want to multiply it by itself. So now when we multiply this, we'll get 8 times 8, which is 64, plus 8i square root of 6, plus 8i square root of 6, and then plus I squared square root of 6 squared. So that'll mean we have 64 plus 16i square root of 6. I squared is negative 1, and the square root of 6 squared is 6. So we really have 64 plus 16i square root of 6 minus 6. So that'll give us the final answer of 58 plus 16i square root of 6. And that'll be our simplified answer. So here we want to solve the absolute value inequality. The first step is we want the absolute value to be by itself. So I'm going to go ahead and divide both sides by 2. That'll give us the absolute value of y plus 3 is less than or equal to 1. Once we have that, we can compare it to a number line with 0 and say my absolute value has to be less than or equal to 1. So I can go 1 this way, or closer, or I could go 1 this way, or be closer. That means our thing here in the inside, y plus 3 is less than or equal to 1, which would fit here. And we also have y plus 3 is greater than or equal to negative 1, which is this part right here. So now when we subtract 3, we'll get y is less than or equal to negative 2. And when we subtract 3 from this side, we'll get y is greater than or equal to negative 4. And this wants us to use interval notation, so we're going to have to list these from small to large, negative 4, comma, negative 2. And since there are equal signs underneath the inequalities, we're going to have to use brackets to describe it. So this is what they're going to want for interval notation of this problem. Now step 2 is going to be the same thing, but now it wants you to describe it by graphing. And based from the interval notation, we know that we're going to want to click this button right here because we use 2 brackets. When we do that, we're going to want to change it to where we have negative 4 and negative 2 on the brackets. So it'll look something like this. And that's all that one is. That's all that graph wants to do. Now we want to solve the quadratic equation by factoring. So I'm going to go ahead and get my factors ready. We're going to need an x and an x. Since we have 2 positives, these are both going to be positive. So we want 2 things that multiply to 42, that when you add them, you get 13. The numbers that are going to fit that are going to be 7 and 6. Once we're here, we have x plus 7 equals 0, or the other option is x plus 6 could be 0, which will make x equal negative 7 over here, and x equal negative 6 over here. So those are our solutions to this quadratic equation when we factor. Now on this next one, we're asked to solve the following quadratic equation using the quadratic formula. In order to do that, the quadratic has to be equal to 0. So I'm going to subtract this 3x that's on this side over to this side. That'll give me 3x squared plus 2x minus 2 equals 0. Now, I'm going to go ahead and write down the quadratic formula, because in this problem all we're doing is plugging these values into this formula. So in our case, x is equal to negative b, which would be negative 2 in our case, plus or minus the square root of b squared, so 2 squared minus 4 times the a value of 3 times the c value of negative 2. And that'll be all over 2 times the a value, which is 3. So the negative 2 isn't going to change. When we do the math underneath the square root, we'll get 4 minus negative 24, which will give us 28 under here. And on the bottom, that'll give us 6. So 28 does not have a perfect square per se, but when we break down 28 into 7 and 4, the 4 does have a root for itself. So we can make x equal negative 2 plus or minus. We can take the square root of the 4 and move it to the outside. So that will be 2 square root of what's left over, which is 7, all over 6. Now the 2, and the 6 are all divisible by 2, so I'm going to go ahead and divide everything by 2 to simplify it. That'll be negative 1 plus or minus the square root of 7 all over 3. Using this with plus or minus as both of the answers will give us our solution to this problem. This problem is asking us, if Denise were to paint her living room alone, it would take 6 hours. Her sister, Colleen, could do the job in 8 hours. So how long would it take them to work together? So we have Denise and Colleen. Denise can clean the room 1 time every 6 hours. Colleen can do it once every 8 hours. Now we're doing it together, so we want to add. And we want to know they can do it together 1 time every how many hours? So we're going to use x. Now in order to solve this, I'm going to multiply the entire equation by everything that shows up on the bottom. A 6, an 8, and an x. When I multiply this to the first term, the 6 is going to cancel. It'll leave me with 8x. The second term, the 8 is going to cancel, and it'll leave me with 6x. The last term, only the x is going to cancel, and that'll leave me with 6 times 8, or 48. So when I add these together, I'm going to get 14x equals 48. By dividing by 14, I get x equals 48 over 14. Now 48 over 14 will not be accepted because it's not simplified. These are both divisible by 2. So I'm going to go ahead and divide both by 2. That'll give me 24 over 7. 24 over 7 is simplified. 24 and 7 have nothing else in common. So that'll make our final answer x equals 24 over 7. Now we're asked to simplify this expression. In order to do that, we're going to need to use the complex conjugate and multiply the top and bottom by that. So looking at the denominator, which is 7 plus I, the conjugate is going to be 7 minus I. So we're going to multiply top and bottom by 7 minus I. On the bottom, we're going to get 49 minus 7i plus 7i, and then minus I squared. On the top, we're going to get 14 minus 2i plus 7i, and then minus I squared. When we clean that up, we're going to have 14 minus 2i plus 7i is the same as plus 5i. And I squared is negative 1. So we really have a minus negative 1 here. Similar on the bottom, only the 7i's are going to cancel. We'll just have 49 minus the negative 1. So 14 minus negative 1, which is the same as plus 1, will give us 15 plus 5i on the top. And on the bottom, we're going to have 49 minus negative 1, or 49 plus 1, which is going to give us 50. Now, all of these here are going to be divisible by 5, so we're going to have to do that. When we do that, we're going to get 3 here, plus just the I, because that 5 will become 1 when we divide it by 5. And the bottom will become 10. I believe you can put it into Hawks this way, but in case it doesn't like it, we can split this up over addition, like 3 over 10 plus 1 over 10i. That is also an acceptable way to write it. Either of these should be fine, though. This problem is wanting us to solve the conjoined inequality here. You have to watch these a little bit, because here for step 1, it only wants us to find the solution set for the first linear inequality. So for this problem right here, we're only looking at this one right now. So negative 5 times x minus 1 is less than or equal to 45. I'm going to start right away with dividing by -5. When I do that, I'm going to have x minus 1 on this side. The sign is going to flip around because I divided by a negative, and that's going to give me -9 over here. Now when I add 1, I'm going to get x is greater than or equal to -8. If I'm going to write that in interval notation, I can start at -8, and on a number line, as long as x is bigger than or equal to, that's everything over in this direction. So there is a bracket because we have an equal sign. However, it can get as large as it wants. And there's never a bracket next to infinity. So our answer is going to be this interval set right here, bracket -8, comma, infinity with a parentheses. The second part to this is going to ask us for the second part, so we're only looking at this one right now. So we have 10 minus x is less than 11. I'm going to go ahead and add the x so I don't have my x being negative. That'll make 10 is less than 11 plus x. And then I'm going to subtract the 11 to get -1 is less than x. We go to the number line. We have -1 here. X has to be bigger than -1, so that's everything over here. And we don't have an equal sign on this inequality, so that's going to be a parentheses -1. And it's going to get as big as it wants, so it can have an infinity as well. That'll be the solution set for the second inequality. Step 3 is going to ask us to describe the overall solution set. Now let's remind ourselves of the previous question's answers. This first part had the solution set -8 to infinity. The second one had the solution set -1 to infinity. And in the middle, and this is important, it says and. So I'm going to put these both on the number line again. Only I'm going to use blue here for the first one. So let's start with Alright, so we have -8 with a bracket, and it's going to infinity. So it has everything this way. And the second one has -1 with a parentheses going this way. Now when we have and, we want to see where this overlaps. And where both of these overlap is in this area right here. So it only overlaps in the area -1 to infinity. Everything over here on this side is only in the first solution set, not in the second one, so it's not included. So the overall solution set in interval notation is just -1 to infinity with both parentheses. And the last part of this problem is going to be describe the overall solution set by graphing. The overall solution set was where we had -1 to infinity with parentheses. So from that, we want to circle this one, and we're going to want to put this bracket, or not bracket, the parentheses on -1, and we're going to want to put the other one on the infinity. And that's how we're going to take care of that one. Here they're asking us to solve the equation, and we have a rational equation with fractions involved. So to take care of this and make it look nicer, I'm going to multiply the entire equation by some number to make the fractions go away. When you want to do that, you're going to make sure that the number that you multiply by up here is divisible by all the numbers on the bottom. So it has to be divisible by 6, it has to be divisible by 12, and it has to be divisible by 12. And I'm going to pick 12 because 12 works pretty good. It's divisible by 12, it's divisible by 6. So when we do that, we're going to multiply 12 here. 12 divided by 6 is 2, so we'll have 2 times 4x plus 3. If we multiply 12 to this, it'll cancel the 12, we'll just have minus 1. And multiplying the 12 into here, we'll also cancel the 12. And we'll just get equals negative 5x minus 8. I'm going to distribute this left part and get 8x plus 6 minus 1 is equal to negative 5x minus 8. I'm going to add 5x to both sides and get 13x plus 6 minus 1 is plus 5 is equal to negative 8. So now I'll have to minus this 5 and get 13x equals negative 13, and then divide by 13 to end up with the answer of x equals negative 1. And since the answer is x equals negative 1, there is indeed one solution, so that's what you'd click on. There will be a box that pops up where you'll type in the answer negative 1. The only other possibilities, if there's no solution, when you tried to solve this out, you would have gotten something like 0 equals 5 or something, which is false. So that would mean no solution. And infinite solutions would be if you solved it all the way out completely, and instead of getting something like x equals negative 1, you got 0 equals 0. Now that it means there are infinite. Those are the two other possibilities you might run into on the test. And one solution is if you have x equals something at the end. Alright, now we need to solve the radical equation. First, I'm going to want to get rid of this 3 on this side and move it over here. So that'll give us the square root of 2x squared minus 11x plus 9 is equal to 3x minus 3. And to take care of the root, I'm going to square both sides of the equation, which will give me 2x squared minus 11x plus 9. And that's going to equal, we're going to actually have to square this out. We'll get 9x squared. We're going to have minus 9x minus 9x, which will give us minus 18x. And then we'll have plus 9. Now, since this is a quadratic, we want it equal to 0. So in order to do that, I'm going to have to subtract the 2x here, or 2x squared here, add 11x, and subtract 9. And I'm going to have to do the same things I do on the other side. Now when I do that, this side is all going to be just a big heaping 0. And over here, 9x squared minus 2x squared will give me 7x squared. Negative 18 plus 11 will give me minus 7x. And plus 9 minus 9 is going to give me 0. So now that I'm equal to 0 here, I can try to factor. I can take 7x out of both of these and give me x minus 1 left over. So that'll give me the option that either 7x equals 0 or x minus 1 equals 0. So my choices for answers is x equals 0 or x equals 1. Now we have to make sure that these work in the original equation in order to keep them as answers. So if I put in 0, I'll get the square root of 2 times 0 squared, which is 0, minus 11 times 0, which is 0, plus 9, and then plus 3 out here equals 3 times 0, which is 0. Now that's going to give me 3 plus 3 equals 0. That is false. That is not true. So 0 is actually a dud answer. You cannot use it. Now let's try 1 just to be sure. 2 times 1 squared is going to give me 2 minus 11 times 1, which would be 11. So that'll give me minus 9 plus 9, which was 0. So we have the square root of 0 plus 3 equals 3 times 1, which is 3. Now 3 does equal 3, so that's all good. So the only final answer we could have is x equals 1. That'll be the final answer that we input into Hawks. And last but not least, it wants us to simplify the following expression, I to the 72nd power. So what we always want to do is we want to rewrite this so that it's I squared to some power. Now, since our power this time is 72, we just need to look at this and see, okay, what would I need to multiply by 2 to get 72? Well, that's going to be 36. So I'm going to put 36 right here. I squared to the 36th power and I to the 72nd are the same thing. What's better about this is we know that I squared is equal to negative 1. So I can input negative 1 into here, and I know that negative 1 to any even power is going to be 1. So that means our final answer, I to the 72nd power, is actually just equal to 1. And that's going to take care of the review. That was actually the practice test. So it would be a very, very good idea to go over this and make sure you understand everything I went over, and make sure you're letting me know as soon as possible if there's anything on here that does not make sense. All of this will be on your test, so make sure you're prepared for it. The only topic that I did not touch on that is important is when we were doing the rational problems, where we had things like x minus 5 or things like that on the bottom, you have to make sure that your answer does not make the bottom of any of those fractions 0. So for example, on the one where there was a problem with 2y plus 1 and y minus 2 on the bottom, now I got negative 7 and 7 for my answers. However, had I gotten 2, you'd have had to have looked back and went, oh, I can't have 2 because y minus 2 would be 0 if y was 2. So you would have had to have thrown that answer out. You have to make sure you do that too. That's the only other thing that I did not get to mention, because the problems I pulled from my practice test that I went over here didn't have a case like that. But it is very possible and pretty likely. So make sure you're watching for that. So I guess without delaying any further, I hope this helps, and good luck on your exam.